A pressure transmitter looks simple from the control room. One number appears on the DCS screen, but that number started as real force from the process. Pressure pushed through a small connection, moved a sensing diaphragm by a tiny amount, became an electrical signal, and finally became 4 to 20 milliamps. In this video, watch the whole chain happen. This is a typical industrial pressure transmitter. The blue housing contains the electronics and display. The metal block below it is the sensor module and process connection. The cable entry carries the loop wiring. Pressure enters from the bottom. The transmitter does not measure a pipe directly. It measures the force that reaches its sensing element. When process pressure rises, the force travels through the impulse line or manifold into the transmitter port. Inside the sensor module, that force acts on a thin diaphragm. The diaphragm movement is very small, but it is repeatable. Higher pressure creates more deflection. Lower pressure creates less deflection. The transmitter now converts mechanical movement into an electrical measurement. In many smart transmitters, the diaphragm changes capacitance inside the sensor capsule. Electronics read that tiny change, temperature compensated, and converted into a digital pressure value. This is the hidden part of the instrument. The electronics then scale the pressure value into a 4 to 20 milliamp signal. 4 milliamps represents the lower range value. 20 milliamps represents the upper range value. The current flows around the loop to the analog input card, where the PLC or DCS converts it back into engineering units. Smart transmitters can also communicate digitally using HART. The analog 4 to 20 milliamp signal still carries the process value. A small digital signal rides on top of it, allowing a communicator to read configuration, diagnostics, range values, and trim information without stopping the loop. In the field, the transmitter may be healthy while the measurement is still wrong. A blocked impulse line can trap pressure. A leaking manifold can slowly shift the reading. The DCS only sees the final signal, so always follow plant procedure, isolation, depressurization, venting, PPE, LODO, and supervisor instructions before touching a pressure system. So the full chain is this. Process pressure enters the transmitter. The diaphragm deflects. The sensor converts that movement into an electrical value. The electronics scale it. The loop carries 4 to 20 milliamps. The PLC or DCS displays pressure. Understanding this chain is what makes troubleshooting possible.